The laboratory brings together scholars and practitioners of learning and complexity science because we're interested in the intersection between the two of them. It was funded initially through a grant from the Jinx Private Foundation, and it brings together projects like the one you're going to hear about today. This was originally funded as part of the lab to explore this intersection between learning and complexity. We think of the lab as not so much a place as an idea. It needs to be a space of possibility where we can try to imagine what if we could really harness complexity? What if we could learn our way through the uncertainty that we experience? This is the kind of work that we are exploring in the lab. And we do provide seed funding for small grants to do that. I'm excited to introduce to you today my colleague, Dr. Caleb Hahn. He's an associate professor of learning, leadership, and organization development at the University of Georgia. And his work is in knowledge sharing and really has tremendous expertise in quantitative research. He looks at social interaction, social network analysis, and uses mixed methods to help better understand the mechanisms of learning in organizations. I'm privileged to be on a doctoral committee for him right after this, where he's exploring some work actually using some of my work on the learning organization. So I'm looking forward to that. Dr. Shenshu Liu, Laura Liu, is also an associate professor in the Department of Educational Psychology and just a extraordinary scholar of methodology and particularly structural equation modeling. She does work in structural equation modeling, longitudinal data analysis, hierarchical linear modeling, and even Bayesian methods. So she's looked at innovative statistical approaches to address some of the ongoing challenges in statistical modeling. We're excited. Please join me in welcoming Dr. Hahn and Dr. Liu.
All right. Now, let me share my screen to give you a presentation. So thank you, Karen. Thank you, everyone, for coming to this session. My name is Caleb Hahn, and this is my analyst colleague, Dr. Laura Liu here. In this talk, I'm going to give you the single most important lesson from the analysis with the data set of Minecraft, so-called DocCraft gameplay, to explore incidental learning through uncertainty and adaptiveness. Before we begin, let me share my appreciation to Dr. Watkins and Dr. Nicolaides and Dr. Jill Jinx, who supported this research. Thank you very much. Without their support, we've never got a chance to explore this interesting data set. Once again, thank you for inviting us into this journey. Well, my colleague, Dr. Liu, and I, we have learned from looking at this amazing data set collected from so-called DocCraft, looking at how incidental learning occurs in our real life, and we pursue empirically how that works. But first, let me put the lesson into context. In our program, I'm the only one who conduct quantitative research in various techniques. While working and growing up, I know I've been like a maverick here, which to me was not a good thing. Thankfully, my wonderful colleague and mentor, Dr. Watkins, has helped me and clear the track for the quantitative research that I can do for the most. In the Illinois, University of Illinois, my alma mater, I was educated and trained as a quantitative researcher, where my love of this method was born. I remember one quantitative psychology professor used to say, "How do you know unless you look?" So we interpreted the word by numbers. And this is what Dr. Liu and I see the world. Today, we're going to present what we learned from the analysis of instant learning from Minecraft gameplay. And this presentation begins with topic modeling and bibliometric for the literature review. And we do explore descriptive statistics and the inferential statistics like a regression and a process analysis. Then we will move on to latent class analysis, further analyzing categorical data, we confirm the descriptive analysis. So to cut the story short, we do not have an integrative literature review process before the analysis. We do rely on rather the review of Dr. Jing's dissertation and her initial analysis. We do by bibliometrics to find out the current status of the topic, instant learning in literature. So for this step, searching for terms related to incidental learning, whether specified the authors mentioned in the titles, abstracts, and included the keywords and the keyword plus in the Web of Science, generated 1,082 articles from Web of Science data. In searching for literature related to relevant context of our study, we prioritize research works where terms specifically related to instant learning. This research found 852 pieces of literature. So we conducted a first review process focused on the language English, peer-reviewed article, and the research area education, psychology, and organization and social science. So this initial review revealed the inclusion of irrelevant papers on language therapy or medical education and so on, that kind of a field, leading us to exclude some of those papers. Bibliometric clustering, computational inductive techniques, hierarchical clustering method made a rich tapestry of complementary insights. So bibliometric analysis provide us with a chart of structural and compositional properties of research articles by clustering, as you can see in a figure, the mechanism rooted in the citation patterns or collaboration networks. As you can see here, in short, instant learning is closely related to the topic of complexity, which is a core theme of this dataset. And coupling network of document shows cited references in collaboration networks. As imagined, Dr. Watkins' 2021 paper placed in the center of a network, see that? They're closely connecting to other articles. So informal instant learning in the time of COVID-19, this article is a core article of this topic. Well, one of my favorite scholars, Jared Diamond, who is in author of Guns, Germs, and Steel, said, life is too complicated. So don't try to find a too simple answer. If someone does, it is a wrong answer. Rather, don't be afraid of a complexity, but try to find the answer through learning. So I think this study gives us a wisdom, how we find an answer in uncertainty. Instant learning occurs unintentionally and it can be a critical area of study within our field, workplace learning, human resource development, and organizational development area. It is essential to integrate theories of learning that acknowledge unplanned, often serendipitous nature of instant learning. This is why we pay attention to this game-based learning. To describe this research framework, we underlined two theories, situated learning theory and the experiential learning theories that emphasize context and tacit knowledge acquisition can be particularly relevant. So these theories suggest that learning occurs through social interactions and the knowledge can be created through the transformation of experience. Here, in our case, DocCraft offers such opportunities. So situating this theory into the practice of a DocCraft case, case, from the play, concrete experience are the cornerstone of both experiential learning and instant learning. In this case, for example, a player might incidentally learn new skills or techniques by using it to complete a task during the play. So this stage of experiential learning aligns closely with instant learning as it involves a direct engagement with the task at hand, often leading to unplanned learning outcomes. In addition, reflective observation involves reflecting on the experience, which is critical for transforming instant learning into more structured knowledge. If a player, for example, takes the time to think about what they learned instantly, they can deepen their understanding and the retention that the knowledge for the upcoming play. So this experience leads the player to abstract actualization And the instant learning can lead to the development of new ideas or creative play based on what was learned unintentionally. And then lastly, active experimentation. Let's say dog craft play involves using the insight gained to influence the future actions and play with the new approaches. Based on this theoretical consideration, overall research question we have for this study is, in what ways does instant learning support or undermine adaptiveness initiatives as a result? So more specifically, we took uncertainty as a context for learning, and the uncertainty can create a high ground for instant learning as players often need to solve unforeseen problems or adapt to new situations without formal guidance. Under these conditions, players are more likely to acquire new skills or approaches instantly through the play, observation, or interaction with the peer players. The necessity to manage and respond to uncertainty can drive players to learn in an ad hoc manner. Rely on immediate and contextual cues. So this is the basic framework of our study. I know that some of you are familiar with this framework from Dr. Jing's dissertation, and we're going to look into that. All right. I know it is getting boring now because we talked a lot about the theoretical piece. So let's move on to the fun part. Okay. So this is the what we found from the data analysis. Looking at the age, about 36% of the total were those in their 30s, but it shows a really diverse group of age, right? Ranging from 20s to 70s. So about 70% were male players. Interesting. And half of them were a novice group, who is the beginner of this play game. More than half played a game 20 minutes or less. Only 10% of them played 40 minutes or more. And looking at the playing time by gender, now we're gonna move on to the cross-step analysis, not just looking at the one categorical data, but the comparison between category. For example, looking at the play time by gender, both male and the female shows a similar patterns, right? But the play time by age shows a very interesting result. 20s and 30s play more than other age groups. Playing 40 minutes or more show concrete differences in this chart. In male group, novice players are predominant. On the other hand, female group shows a balance in experience level. And in uncertainty response, in average, 30s shows the lowest mean score, but many outliers on the upper hand. So, well, we can see many outliers in 30s with a very variance in this group. Instant learning. Instant learning, 60s shows the highest mean score, as you can see, but many outliers on the bottom this time. And adaptiveness as an outcome variable was 13.5%. We can see adaptiveness in this case, the 7 years is the lowest mean score and the one outlier. And we're going to move on to the simple regression here with the demographic variables. The outcome variable here in this regression model is adaptiveness. This outcome variable was 13.5% explained by demographic variables. And here in this model, age, experience level, and the play minutes are significant variables. Next, we adapted another research analysis technique, and we moved on to the regression model with the two significant factors, uncertainty and instant learning, not informal learning here, typo. It shows that both factors are significant and that they have a significant impact on adaptiveness. For uncertainty, it has a negative impact, and the instant learning has a positive impact. And to combine them all in this regression model, we can see that age and play minutes are significant variable, and uncertainty and incidental learning are significant variable to explain the adaptiveness. So this is a simple regression model. We can see the similar result from Dr. Jing's dissertation. But I want to expand this model with the more complicated process, and we adapted another research techniques here, conditional process analysis. This technique was used to examine the extent to which mechanisms by which an effect operates depends on or varies across a situation, context, or individual differences. So we made this research framework consider uncertainty is a contextual factor, and demographic variables are individual differences. So in this model, as depicted in a figure below here, we are going to look at the interplay between incidental learning and adaptability in certain uncertain conditions. So based on this model, we made the several hypotheses. Uncertainty prompts incidental learning. The player faced with the new unexpected situations must rely on immediate problem solving, which often lead to learning new information or skills instantly. And this instant learning enhances adaptability. The skills and the knowledge gained through instant learning equip the player to better handle future uncertainties, enhancing their adaptability. Of course, here in this model, instant learning plays the mediating role between uncertainty and adaptiveness. And we want to see that how this mediating effect can be moderated by individual differences, for example, age, gender, and experience level, and the play minutes. So we can discern that for the model with the process analysis, and we're gonna look at the moderated mediating model effect of individual differences and instant learning. So as you can see, both age groups, as uncertainty increases, incidental learning decreases, suggesting that uncertainty negatively impacts learning outcomes. However, the slope, as you can see, the right hand, the figure on the right hand, the slope of the line representing the high age group here, 40 years or higher, is steeper compared to the low age group. 40 years or lower. This suggested that negative impact of uncertainty on instant learning is greater for the high age group. In other words, that means age moderates the effect of uncertainty on instant learning, with the implication being that older players may find their learning more adversely affected by uncertainty than younger players. And we're going to move on to the moderating role of gender. In case of a moderating role of gender, the graph illustrated that with low uncertainty, there's less incidental learning for males. As indicated in the figure on the right hand, a dotted line, uncertainty goes up. The level of incidental learning for males slightly increases or remains relatively stable, as suggested by the upward of a flat trajectory of the dotted line. But for female players, represented by the solid line, the graph shows a clear downward trend, indicating that as uncertainty increases, incidental learning decreases. The comparison between the two lines demonstrates the gender-based difference in how uncertainty affects incidental learning. So this result suggests that there is a moderating effect of gender on the relationship between uncertainty and instant learning. Specifically, it implies that males may respond to high uncertainty with a slight improvement or no change in instant learning, whereas females experience a decrease in instant learning under similar conditions. So this would point to the buffering effect of a gender where males' instant learning is less negatively impacted by high uncertainty compared to females. So this was a very interesting result. For individuals here, novice group, as denoted by the solid line with the square markers here, we observed a downward trend from left to right. So this suggests that as uncertainty increases, incident learning decreases for this group. So this negative relationship indicates that less experienced individuals may find their learning is more negatively impacted by a rise in uncertainty. In contrast, the dashed line for high experienced individuals, expert group here, maintains a relatively constant level of instant learning across the levels of uncertainty. So this implies that the level of instant learning for individuals with a high level of experience is not significantly affected by the degree of uncertainty they face. So the divergence between these two lines demonstrated that moderating effect of experience on the relationship between uncertainty and instant learning. Specifically, the figure suggests that the individuals with a high experience are likely to maintain their learning outcomes despite the presence of uncertainty, whereas those with the novice group is more negatively affected. And we can see that the mediating role of instant learning, the relationship between uncertainty and adaptiveness here. And finally, we hired the play time as a moderator. However, this does not have a significant effect on the relationship. So only mediating role of instant learning between uncertainty and adaptiveness was confirmed. So in this model, we only see the mediating the relationship between three important constructs here. So now I'm gonna hand Dr. Lu the microphone for the presentation. And Dr. Lu, is your time.
Thank you. Thank you, Dr. Han. Thank you, Dr. Watkins. Yeah, thank you for your invitation to join this amazing project. And also, thank you, Dr. Jinx. Yeah, actually, what we have already done actually is based on your previous research, mostly based on your dissertation. You did a really, great job, wonderful job in your dissertation. So my job is mainly do the classification because we have around 400 observations or 693 observations. So we're trying to do the classification to see which individual or which observation belongs to which group. So we use a latent class to do the analysis. So in the very beginning, I started from the GILS, the Dr. Jinx EFA results. Thank you for changing the slides because I don't think I can change. I can change it here. Okay, yeah. Not here. Okay. Before the research question. Okay, yeah. Okay, we are going to investigate latent classes because latent classes are not observed here. So we needed to use a statistical method to try to look at the probability of each individual belong to each group and then do the classification. And our research question in this part include 4 topics. So the first one, are there any similar patterns or similar behavioral patterns among the participants? Based on their output, based on their uncertainty, based on their crafting ability and adaptive ability, and their incidental learning ability, we're gonna do the classification. So that's the first question. And if so, how many classes are there? And the second question, what specific patterns what kind of patterns can we observe? So that is the second research question. And third one, so which participants belong to which class, which latent class, or they exhibit some similar behavioral patterns. So we can just do the individual classification. So yeah, we're gonna give their specific class for each of them. And the fourth research question is that what factors influence their classification? So we mainly focus on 4 factors. Okay, age. So age gonna influence the classification, or gender, the female and the male. Okay, or experience level. So in JEO's data, we have 4 levels: 1, 2, 3, 4. Okay, so 4 means high and 1 means low. And also play minutes. Is the longer, the better? Or what is the influence of the play minutes? So based on these 4 research questions, I conduct the latent class analysis. So could you please give me the next slide? Yeah. So this is a result from Jinx. Okay, so it's one of her tables. So she provided a lot of tables. So this is one of the EFA table. Based on her EFA result, EFA modeling. So one of the latent factor called individual incidental learning are actually measured by these observed variables. So she used a questionnaire and she collected a great amount of data, and all of these are items can be grouped together, and she named it individual incidental learning. So let's look at these items. For example, so one of them, the first one is called use other experience to figure out something. Okay, this is one item. And also try stuff. If it doesn't work, try other stuff. Experiment with different idea. Okay, and leverage how I play other games. And all of these items are measuring the same latent factor called individual incidental learning. Okay, that's one of factor. So could you please go to the second slide? Yeah, next slide. And also, she found another latent factor called uncertainty. So this is measured by the following items. For example, okay, when uncertain get uncomfortable with it all, and kept worrying something going wrong, or no clear way forward, get frustration. So anyway, all of these items are measuring the same latent factor, which is called by Dr. Jinx uncertainty. Okay, and then the next table, yeah, the next slide. It's adaptiveness. Okay, adaptiveness is measured by some items. For example, okay, during the game, I coped with changes. Okay, during the game, I adapted well to change. So you can see that all of these items are actually measuring the people's adaptiveness during the game. And also, she found the fourth factor, latent factor, called crafting. So it is measured by dig, crafting, interact, crafting, place, crafting, and place basics. So what I've done actually based on these 4 latent factors and do further analysis based on these scores. Okay, these 4 latent factor performance, and I try to do the classification. So could you please go to the next? Yeah. And first, I rename those items. If it belongs to the individual incidental learning, I just gave them a I. Okay, from I1 to I10, 10 items. And for crafting, so 4 items. For uncertainty, so from U1, uncertainty 1 and to U8, 8 items. Adaptiveness from A1 to A6. So by using these items together, we just look at the classification. Okay, next slide. So let's look at the first research question. is there any similar performance behavioral patterns among these participants? And if so, how many latent classes? So in the very beginning, I just try different latent classes. Of course, one class, it will be ignored because if it's one class, then we don't need to do further analysis. So I start from 2 latent classes. So look at this table. So in the first column is number of profile or number of classes. You can say it a profile if the outcome is continuous, or you can say it a classes if the outcome is categorical. So let's see it's a profile. So we have 1, 2, 3, 4. Okay, we have 4 groups analysis. So please keep the previous table. Thank you. The table 1. Okay, so we have the first part. It's called a model fit. For each profile. For each model with different profile, I look at the log likelihood value, AIC value, BIC value, SSBIC, SSABIC value. So all of these are for model fit. Okay, these are kind of like a model fit indexes. It tells us which model should be better. And also we have the second part. It's class. Okay, classes. So I have 2 kind of indexes, entropy and the smallest class probability. So what does that mean? So entropy actually is an index to tell if the classification is good or not. The higher, the better. So if that value is close to 1, then maybe the classification is really good. And the smallest class probability. So let's check because we have so many classes. Okay, so for example, we have class 1, class 2, class 3. So let's check the smallest class probability. So if one of the class probability is less than 5%, some people suggest that, okay, this may be not good classification because one class is the proportion is too small. So let's try to make it each of these classes kind of like equally spread. But of course, the truth, it may not be this case. But I also check this probability to see which number of the profile will be the best choice. And the last portion is likelihood ratio test. Okay, so we're gonna compare the current number of profile to the K-1 profile. Okay, so I do the comparison between 2 models, and the likelihood ratio test will tell us which model is better. So we just check the difference chi-square value. And then based on the chi-square difference, we look at the p-value. So if the simplified version model is significantly worse than the full model, which is the current model, if in that case, if it's significantly worse than the full model, we should use a full model. If it's not significantly worse than the full model, then we use a simplified model because the simplified model has smaller number of parameters, which is simpler, which is better for us to do the interpretation. But if it's significantly worse than the full model, we're gonna keep the original model, the full model. Okay. So based on the comparison, let's look at the final column, preferred. Still the table one. Yeah, let's look at the last column, preferred. Actually, when we do the comparison between 2 profiles and 1 profile, the 2 profiles chosen is preferred because when you check the p-value, it is significant. Okay, it is significant. And so what does that mean? So that means that 1 profile is significantly worse than the 2 profile. So we're going to choose a 2 profile model. And when we do the comparison between 2 profile and the 3 profile, or 2 latent classes versus 3 latent classes, the result tell us the 2 latent classes model will be better. Because let's check the p-value, the probability. It's not significant. It's 0.6243. So that means these 2 models are not significantly different. So we still needed to look at the 2 latent classes because the number of parameters will be much smaller than the 3 latent classes model. And also, if you do the comparison between 3 latent classes and 4 latent classes, 3 will be chosen. But of course, because 2 and 3, after the comparison, 2 will be chosen. So we use 2 latent classes. And the first table is actually analyzed based on without any covariate, without age, without gender, without experience level, without the play minutes. But the second table, okay, the table 2 actually investigated by including all of these covariates. So the results are consistent. Okay, you can see that the 2 latent classes model will be preferred among all of these. And then next slide, I'm gonna use 2 latent classes, and that's the result. Okay, so what specific patterns, if we assume there are 2 latent classes? So I have 2 kind of parts. Okay, the first part is for latent profile or latent class 1. The second part is for latent profile 2. So we can see that for each item here, so from I1 to I10, from U1 to U8, A1 to A6, and C1 to C4. So all of these, the estimated standard error, the ratio, and the p-value are reported here. But these are just numbers. This is a huge table. It's very hard for us to tell their specific pattern. So I just draw the plot. So could you please go to the next slide? Yeah. I just draw a plot for these 2 latent classes. Now it's quite clear. So we have 2 latent classes. I use different color to show them. So one is a blue color, the other one is red color. You can see that the blue colored line actually has lower incidental learning ability. So I have 4 parts. Okay, so the first area is for individual incidental learning ability items. All these items are grouped in the first area. And the second area are for uncertainty. Okay, the third area are for adaptiveness. The fourth area are for crafting ability. So you can see that for the blue line, they have lower incidental learning scores. Okay, so the blue line is lower than red line. And in the second area, the blue line has higher uncertainty scores. And the third area, the blue line has lower adaptiveness scores. Okay, and the fourth area, crafting ability, also the blue line is lower than the red line. So based on the performance here, my conclusion is that, could you please show the words here and on the top part? Yeah, my conclusion is that the blue line actually has lower incidental learning ability, higher uncertainty, lower adaptiveness, and lower crafting scores. I just name it novice group. So if people belong to this group, it's novice group. And of course, we have red line. So could you please show me the second conclusion? The red line, the red classes, okay, has relative higher individual incidental learning abilities and lower uncertainty scores and higher adaptiveness scores and higher crafting scores. So obviously, these people are more experienced. They are more confident. They are more kind of like learning ability. They are more adaptiveness. They are doing more crafting. So I just call them experienced people. So by now, we have 2 latent classes, which are novice group and experienced group. Okay, so that's the second question. So let's look at the third research question. Yeah, okay. So I'm sorry, this is a huge table. So yeah, let's look at the last column. Okay, the last column is a class membership. So for each individual, actually, okay, so the number of rows are actually the number of observations. So we have 993, right, observations. So all of these are listed here. And the last column just give their class membership. So for example, the first row, okay, the first individual, and does it belongs to class 1 or class 2? Okay, and the second individual, so class 1 or class 2, is that novice or is that experienced player? So we do the classification. So sorry, the last column just gave the membership. That's a third research question. Okay, let's look at the fourth research question. Okay, now let's look at the what kind of factors gonna influence the classification? Is that because of age, because of their age? Is that because of their gender, or the experience level, or the play minutes, the play time? So I conducted logistic regression with all of these 4 as our covariates, okay, to see which one is significant, which one is not significant. So that's a result table. So I use a reference group as class 1, which is novice group. Okay, novice group is our reference group, and the class 2, which is experienced group, as our kind of outcome. So the class number 2 is actually based on age. You can see the last column, the p-value. It is marginal. Okay, so if you think that 0.05 is the alpha level, that it's not significant. But if you use 0.1 as the alpha level, then it is significant. So age is marginal. And let's look at gender. Gender is not significant. So what does that mean? So male and female will not gonna influence their classification. So novice and experience, so that's not based on gender. And then experience level. Of course, okay, experience level will be significant, and it is significant. Let's look at the p-value. It's almost 0. Okay, it's very, very significant. So let's look at the play minutes, play time. It is also significant if the alpha level is 0.05. Okay, so you can see that if the play time is longer, then it's more likely to be an experienced player. Okay, so that's the logic. What is logic? Okay, logic regression actually use log odds. Okay, log odds for the dependent variable. It's not the traditional outcome. Okay, because the outcome here belongs to class 1 or belongs to class 2. So that is binary outcome. So we have to do the transformation. So we use log odds to do the regression. So let's do the further analysis. Let's look at the interpretation. Okay, what does that mean? So let's look at the next slides. Okay, let's look at the odds ratio. Because the dependent variable is log odds, then let's do the exponential transformation and look at the odds ratio of all of these 4 factors. And now you can see that we have ratio. So for age, for gender, for experience, for minutes. So how to do the interpretation of them? So next slide. Let's look at the age first. Okay, so age, actually the odds for the age is 0.984. Of course, we have some standard error, we have lower bound, we have upper bound. Okay, so how to do the interpretation of this part? Actually, this is 0.984 tells us the change. Okay, the change of the odds ratio is 0.984. What does that mean? If I increase 1 unit in age, so what does that mean? If the people is 1 year older, then what is the change in the odds ratio? So the change, okay, so odds, the top part is a ratio. Okay, the top part is the odds of age plus 1. It's 1 year older. The bottom part is odds of age, the current age. So what is the change? It is 0.984. So it get decreased. What is odds? Okay, the next part is for the odds explanation. It is a probability of being an experienced player to the probability of being a novice player. So that ratio is called odds. Okay, if you belong to class 2 or class 1, class 2 means experienced, class 1 is novice. So what is the ratio? What is the ratio of these 2 probabilities? Of course, if the ratio is larger than, if the ratio is 1, what do you think? Okay, so if the odds ratio is 1, then the probability of being an experienced player equals the probability of being a novice player. So it is 50-50%. If the odds is 1, it's equally spread. Okay, so we have 2 kind of like 50%. But if the odds is larger than 1, then it's more likely to be an experienced player than the novice group. If the odds is less than 1, Okay, it's less than 1. It's less likely to be an experienced player than the novice group. And the that's odds. Okay, that's just odds. And odds change. So the change of the odds is expressed by the above equation. So 0.984 is a change of the odds. So the odds actually get decreased if the people get 1 year older. And of course, it's not significant, okay? Based on the previous p-value, it's marginal. It's 0.069 something. Okay, it's marginal, but it's not very obviously. Let's look at the experience level on the next slide. Experience level. Okay, we expect this factor gonna significantly influence the classification, and it is true. Okay, so let's look at the odds ratio of experience level. It is 1.869. So that is a change of the odds ratio. So what does that mean? If I increase 1 level in this item, experience level, it's 1, 2, 3, 4. We only have 4 levels. If we increase 1 unit in this item, then the change of the odds ratio will be 1.869, so which is big. So that means, okay, the higher experience level, the higher odds. The higher odds, the more likely to be an experience level. So that is the conclusion for the experience. Okay, then let's check the last one. Last one, play time. Okay, minutes. Again, it is significant. And the ratio, the ratio change is 1.025. Okay, so if we increase 1 minute, okay, if we stay in the game 1 minute longer or play that 1 minute longer, then the odds ratio change will be 1.025. Still, it's larger than 1. It's increased, so the odds becomes larger. So to be the experience, the probability is increased. So it is significant. Okay, so finally, if we have a conclusion, that means, okay, the experience level gonna significantly influence the people's classification. If they have higher level of the experience, okay, if suppose it's 4, then it's more likely to be classified into the experienced player group. But if the experience level is low, then it's likely to be grouped into the novice group. And also play time. Okay, play minutes. The longer the player used in this game, then it's more likely to be an experienced player. And what else? Age, it's kind of like, okay, it's decreasing, but it's not significant. So that means with a higher age, maybe the probability of experienced player, maybe it's not so high. It becomes smaller. Okay, so for gender, which is not significant, okay, for female and male, we do not have significant impact. So you can see that actually the conclusion are consistent with Dr. Han's conclusion. So we use a different approach, and we see the same result, the same conclusion. And we also investigated the importance of these 4 covariates. Okay, and I think that's all what I did. Yeah, thank you.
Fascinating to see this evolve one more time, isn't it, Jill?
It's just amazing, Dr. Han and Dr. Liu. One, both of you taught me, but to take a different look with different questions around the same data. I'm learning so much about this because we were looking at intervention, and you've kind of set that up again with the intervention index that we have the patent outstanding on. So I can't wait for you guys to write this up. I think there's something powerful here, and I'm honored to get to hear it first time. So thank you so much for incredible work. And I know this is Dr. Watkins. She owns incidental learning, and now you got numbers, girl.
That's right.
Write its ass up and publish it.
Yeah,
Go dogs.
It needs to be. I think putting these things there's a lot, what is it? Somebody said that a lot of time our findings look like common sense, but on the other hand, we found it, we proved it and showed it. And so I think that's what you're doing here. Yes, it makes a lot of sense that the greater the uncertainty, the more you're going to have to adapt and the more you're going to have to learn, right? And to be able to show what might impede that learning, like some of our given characteristics, age or whatever, but also to just simply show the relationship is real, and that it varies by a particular amount, right? So in the certainty, there's a certain level of uncertainty I can't handle probably, and incidental learning isn't going to be enough. So seeing that and be able to show it numerically is lovely.
What's interesting is when you relate that back to Robert May's formula, which is what we used for the intervention index. This sort of validates his conclusions around there are places where you are in chaos and you cannot get out. So the system will dissipate. And what this is doing is saying there is a place where dissipation is on the horizon. And that dissipation as a human is I withdraw, I need intervention, or this is my strength. It's like me, I can't do geometry, we're done. So having that ability in an industrial situation where you can have employees or workers or learners, whatever you want to call them, understanding how to place them, when to intervene, the kinds of interventions. Now, we don't get into kinds of interventions here, but this is all super consistent with the intervention index. I mean, we got to write the whole thing up. From my perspective, it's game changing.
Not to make a pun. What else? This is a gigantic data set. So taking it on,
yes,
big thing, Caleb and Laura. What else do you think needs to be done with this data set? What are the next studies that could be, could it yield, I guess?
A lot. Actually, what we have done, just small part of that. Because I noticed that the geo has 4 waves. Okay, so for each player, they have final 4 surveys. So originally I was trying to look at the longitudinal change. So starting from the first wave to the last wave to see if the participant get a growth. Okay, if
I'd love to see that.
Yeah,
but I don't know how.
But because of the sample size is not so big for each wave,
right?
Because we have 4 waves. So, I was trying to conduct the latent class. Yeah, we can do that later. So, we can do that. We can do that. Although the sample size is not large enough.
Oh, it sounds really hard, but I love that idea of observing change over time. That's great.
That was it. And I think one of the things that we were doing with this study was kind of proof of concept. Do we want to run the study again at the University of Georgia? We ran it at a small liberal arts school, but do we run it a larger study to really get in and get this kind of data? To me,
you should apply for a big grant.
Yeah, that's what you're supposed to do.
Yeah, I can see the potential. Yeah, you should use the NIF, NIH or NSF to apply.
Only if you help. Only if this team helps, right?
Yeah.
Because I do think it's an NSF project, and I would love for us to take this to the state of Georgia to run either not at the high school level, but the teachers. There are plenty of populations that we can take the methodology to. Mm-hmm. And as we learn more about it, it is NSFable, but that's not my world. That's y'all, right? That's you guys taking an NSF approach to it.
Yeah, I think we should publish some papers based on the result, and then maybe later on we can just use this paper as our foundation and do the grant application. I can see a lot of work we can do. Yeah. So I can tell you later on. So a lot of model can be applied. Yeah.
Sure.
Yeah.
Caleb, what do you think?
Oh yeah. I want to talk about the role of AI as well, because previously it is hard to capture instant learning. And this study just to show the first chapter, how can we measure instant learning, and what's the social interaction, the role in that play between uncertainty condition and adaptiveness. And I think that I just tried to do that. The natural language processing systems captures that how individuals interact with each other and what's the patterns of interaction. What is the specific patterns of a language they use during the play? The kind of things that are part of our process. I mean, these things can be improved by AI integration into play. And plus, we can also provide the customized, personalized learning process to individual learners. Instant learning is not intentional, it's unplanned, but we can see the patterns of instant learning during the play through the systematic approach toward that, and we can provide a personalized learning process. This is the way you can get the best answers in specific situation. So AI can help that, and then this application will be a great example in organization and the workplace learning as well. So the AI, when it comes to AI application, we have a variety and a broad spectrum we can explore in the future research.
That's really neat. Are there any questions from our guests? We have people that are needing to leave, so I wanted to make sure.
Well, I hope we get the opportunity to see your work published, Dr. Han and Dr. Liu. It's really I've not seen anything else like it, like what we're talking about here. And I would love to see the critique of the methodology so we can learn from, where are our blind spots.
That's great.
Yes, yes.
Well, I want to
Thank you all for
both
engaging
so
with
much for doing this. I'm sorry, who said that?
That was me. I'm just thanking it. I
Okay,
was just honored to be here and watch it. It's
great.
It's like watching your kid play baseball.
All right.
Which is pretty cool. Well, we hope you enjoyed this session, and we also hope that people will return for more of the projects that we are conducting through the lab. We are one of the few complexity labs in the world, really, that look at learning and complexity. So I think that whether we're looking at learning in the face of uncertainty, precarity, or complexity, or even just how complexity impacts learning, as in this study, the lab is the space where we're trying to explore it. And so we hope you'll come visit us again. A very special thank you to our distinguished guests, Dr. Han and Dr. Liu, to Emily Klein for all she does to ensure that we are able to offer these sessions, to Jill Jinks for doing the study in the first place that created the data that we could work with, and to all of you for joining us today. Thank you.